So today again good evening. So today's second topic is difference between the analog and digital transmission. Myself B Kashinath, senior lecturer in electronics and communication engineering from Government Polytechnic Sangareddy. So the subject is data communication and computer networks, and, and the subject code is 18EC 503C, and the topic name is difference between analog and digital transmission. So in the previous class we have learned about what is data communication and networking and need for data communication and networking. So what is computer networks? So computer network is what? So two devices or two nodes which are sharing the data. So the data communication means again the standards and procedures set for efficient transmission of data, secure transmission of data between the two nodes, that may be using the wired or wireless media. For that we are having the set of protocols. So protocols defines the how and when and what to send the data, what to send the data, how to send the data, and when to send the data between the transmitter and receiver by using the transmission media. So that is the what need for data communication and what is communication, data communication and networks. So in this class what we are learning is what is analog signal, what is digital signal, and comparison of the analog and digital transmission, comparison of the analog and digital transmission. So what is analog signal and digital signals? So what is analog signal? A signal which is continuous with respect to time. A signal which is continuous with respect to time, we are calling it as analog signal, and the examples are sound and video, temperature and pressure. So these are examples of the analog signals. So what is digital signal? Signal which has discrete values or discontinuities with respect to time. So it is the signal which is not continuous with respect to time or discontinuous with respect to time, means for some time it is having some value, for some other times it is not having some value. So that type of signals we are calling it as digital signals, like your pulse signal or step signal. So analog signal is what? Which varies continuously with respect to time. Examples are sinusoidal signal or output of a microphone when the speaker talks over it. So this is the analog signal. So this is the sinusoidal signal. So x axis you will be having the time, y axis you will be having the amplitude, and with respect to time the amplitude is continuous. So for every part, every second in the time axis the amplitude is there. So it is the analog signal. So the amplitude is continuously changing with respect to time and it is continuous in nature. So this signal we are calling it as analog signal. So when such a signal is, when this type of analog signal is transmitted over cable, means through transmission medium, what happens is noise will gets added to the amplitude of the signal. What happens? Noise will be added to the amplitude of the signal. So the analog signal may get distorted due to noise and due to non-linear properties of the transmission media. So first noise is added to the analog signal, and due to non-linear properties of the transmission media also noise is added. So totally the signal will be get distorted and cannot be reconstructed at the receiver side even by using the amplifiers. So this is what analog signal, like somewhat another this is not a sinusoidal signal, but it is a continuous signal. So we are having time or space, and y-axis we will be having the intensity. So like this we will be having various analog signals in the nature. And digital signal is of discontinuous in nature. So discontinuous means absence of the pulse is regarded as 0. If the pulse is present, it will be regarded as 1. So in digital signal we will be having only 1 and 0. If 1 is there, we will be having the presence of pulse. If 0 is there, then we are considering it as absence of the pulse. So during the transmission of these such pulses, even if noise gets added up, it will not create a problem. So if the signal is there, it will be problem. If the signal is not there, means if you are sending the 0, if the noise is there, it will not create not that much problem with corresponds to analog signals. So this is because of the demarking of 0 and 1 with respect to a one threshold point. So we will be making one threshold point. So if the signal crossing that point, we are making it as 1. If the signal is below the threshold point, we are calling it as 0 level. So if the noise is added also below the threshold point also, no problem for us. So digital signal representation will be like this. So pulse high means it is 1, low means 0. 1 means high, low means 0. So while with digital transmission, many techniques like data encoding, data encryption, data compression, high data rate of transfer, noise immunity can be obtained. And some of the differences between analog and digital transmissions are: analog data take on continuous values of some interval, digital data take on discrete values. So analog will be continuous in nature, digital will be discrete values, only 0 and 1s. So analog signal occupies the same spectrum as analog data. Digital signal consists of two voltage levels to represent two binary values. To transmit the analog data over long distances, amplifiers are used to boost the energy of the signal. Whereas in digital, to transmit the digital data over long distances, repeaters are used to recover the bits. Here we are using the amplifiers, here we are using the repeaters. So analog transmission is a means of transmitting the analog signals without regard to their contents. So whatever the content will be there, we have to transmit. So digital transmission is concerned with the content of the signal. So here noise level is more, here noise level is less. Transmission cost in analog side it will be more, in transmission system cost in digital side it will be less. Transmission speed is less in analog side, it is more in digital side. Transmission power requirements are more in analog side, transmission power requirements are less in digital side. The distortion and noise interference are cumulative over the entire transmission path. In digital, they are not cumulative. So bandwidth requirement is less in case of the analog, bandwidth requirement is more in case of digital transmission. So these are the how they are looking like. So analog signal is continuous, digital signal is discrete. So summary is analog data taken on continuous values on some interval, whereas digital data take on discrete values. Analog transmission is power requirements are more, bandwidth requirement is more, speed of data transmission is more. Analog transmission system cost is more, whereas digital transmission system cost is less. So finally the quiz, dash signals are continuous in nature. So the answer is analog signals are continuous in nature. Dash signals are on off in nature. So which signals are on off? Digital signals are on off in nature. Which of the following is wrong for analog transmission? So bandwidth requirement is less, transmission power is more, noise level is more, transmission speed is more. bandwidth requirement is less. Compare digital and analog transmission methods.